Hey guys, we're going to start 7.3 today. We are simplifying, multiplying, and dividing rational expressions. I believe all of this we have done before, so this should be all just review. Okay. So I have a couple of different select problems I'm going to do. I'm going to explain which ones I'm going to do on this paper, and then I'll switch just to the video so you'll see. So for the first section, I'm going to do numbers 1, 3, and 5. This section, I'm going to do numbers 7 and 11. We'll talk about 13 in just a second. Then in the next section, I'm going to do 16, 17, and we'll finish with number 18. Okay. Before I switch to this video, let's go ahead and do 13. It says compare the function this to the function x minus 5. Notice here's x minus 5. Here's x minus 5. Here's x minus 5 right here. So all they did was multiply x minus 5 by this, but it's the same top and bottom. Okay. Well, whenever I have something divided by myself, notice I could just cancel this out, and then I would have this, which is the same. Okay, so f and g are really the same. Okay, if I graph them, they're going to look exactly the same. There's only one difference. Okay, this is an important difference though, is that, well, before I cancel these out, we actually learned that when I cancel two terms like this out, it creates a hole in the graph. And it creates a hole in the graph whenever this equals 0, because again, the denominator cannot equal 0. Well, if I try to solve this, subtract both sides by 1, I'll get 4x equals negative 1, divide by 4, divide by 4. I would come up with x equals negative 1 over 4. Okay, so f is going to look just like g, and if I do this like on my calculator, my TI-84, I wouldn't even be able to tell the difference between the two unless I tried to figure out what f was when x is negative 1/4, and then my calculator gives me an error because f has a hole at negative 1/4, whereas g, I can just plug negative 1/4 in. But as far as everything else, they're going to look identical. Okay. Let's just do that all. Oops. There we go. Here we go. All right, so I wrote these out to save time. This is a rule that we've talked about before, but it comes back into play today. So when we get to that problem, I'm going to follow that. For number 1, we don't need this rule though. We're just going to see what can I simplify out of everything. Well, let's start with my numbers. I have a 5, a 2, and a 3. Is there anything that divides into 5, 2, and 3 evenly? And the answer is no, there's not. So I'm going to leave them just like that. And then move on to the x. Well, there's x squared, and x. Well, they all have an x. So I can cancel out an x in each of them. How many x's can I cancel out? Well, whatever the lowest exponent I see is, that's how many x's I can cancel out. This one only has one x, so I can only cancel one x out of each one. Well, that's going to leave me with 3x on top, 5x plus 2 on the bottom. Okay. What if I get something that looks like this? Well, I can still try to see if anything cancels out of everything. There's not, but there's a little bit more I can do. I can factor. Okay. I'm going to try to factor without using the box, just because I don't have a lot of space on this paper. But again, if you want to factor using the box, that's fine. So I have x and x. I'm multiplying to make 5. Well, the only thing that multiplies to make 5 is 5 and 1. I want 5 and 1 to add to make negative 4. Well, that means I need the 5 to be negative, the 1 to be positive, and that way negative 5 times 1 is negative 5. Okay. Do the same thing down here. X, x, What multiplies to make 10? Well, 10 and 1 or 5 and 2. They add to make -7, multiply to make +10, so they both have to be negative. Well, now once I do that, I can see, oh, I have an x minus 5 and an x minus 5. Those two are the same. And I can cancel those out. If I cancel those out, I'm left with just an x plus 1 on top and an x minus 2 in the bottom. I could put them both in parentheses if I wanted to, like they were here, but because there's nothing else beside them, I don't have to. Okay. For number 5, I'm going to do the top just like I did here. First, I will see, is there anything I can cancel out of everything? Well, these two don't have x's in it, so I can't cancel out x's. And of course, these two don't have any coefficients other than 1, so no. So let's just factor the top. X, 2 times 1 is the only thing that multiplies to make 2. They have to add to make a negative, so negative. Multiply to make a negative, so they have to be different, so negative, positive. Okay. And then I have this right here. Well, this is called a difference of cubes. And maybe to make this easier, this is x cubed minus 2 cubed. 2 cubed is 8. That's an important way of writing it, because up here I have my sum of cubes can be factored into this, difference of cubes factored into this. Well, this one's a difference, so I'm going to use this bottom rule. So I'm slide that up just a little bit, and I'm going to use this rule. Well, my a is x, because I have x cubed, it says a cubed, minus my b isn't 8, my b is 2, okay, because it needs to be b cubed. So my b is 2. So I'm just going to plug x and 2 in for a and b in this equation. So I'm going to start off with x minus 2, that's my a minus b. And then I have a squared. Well, my a is x, so that's going to be x squared, plus a times b, that would be 2 times x, or 2x. And then b squared, well, 2 squared is 4. Okay. And then let's see, well, can I cancel anything out? Yes. Cancel that and that. What does that leave me with? Well, on the top, it leaves me with x plus 1. On the bottom, it leaves me with this. Well, I'm tempted to say, well, maybe I can factor this out again. If you get it from the difference or sum of cubes, you're not going to be able to factor this out again, because you're going to get 2 positives, so 2 and 2 are the only things that multiply to make 4. They both have to be positive, and 2 plus 2 don't equal 2. So this is not going to be able to factor. So I'm going to leave it x squared plus 2x plus 4. Answer. All right, well, let's move on to multiplying. When I multiply, I want to just cancel stuff out before I do really anything. So let's start with my constant, coefficients. I have a 54 here, I have a 1, and then a 9. All right, well, top and bottom, I'm allowed to simplify or cancel stuff out. So I could go ahead and divide that, but sometimes that confuses people. So I'm just going to multiply the coefficients across. 54 times, well, this is a 1, is 54. 1 times 9 is 9. And then I'm just going to go ahead and combine my heads across. I could cancel out, but again, so that I don't try to confuse anybody. X to the 4th, x cubed makes 4 plus 3 is 7. So to add x on. Y squared, y to the 4th. The bottom, this one doesn't have an x, so it's just going to be x to the 5th. And y4, y3, y to the 7th. Okay. Now, to simplify this one further, I'll start looking at my numbers. I got 54 over 9. Well, what divides into both 54? 9. Well, I'm pretty sure 9 divides into 54 evenly. I'm going to pull my little calculator up here. Let's see if you can see it. Maybe. Let's see. 54 divided by 9 is 6. Okay, so 9 goes into 54 6 times. So that means I'm left with a 6 on top, and I could put a 1 on the bottom if I wanted to. Let's look at my x's. Now, when we have x's, when we're dividing, we're going to subtract the exponents, and I want to move them to where the largest exponent is. So here, my largest exponent is 7, and it's on top. So I'm going to say 7 minus 5 is x squared. It's on top because that's where the larger exponent was. With my y's, my larger exponent's on the bottom, so that's where my y is going to end up. So 7 minus 4 is 3. And of course, I could move the y up by making the exponent negative, but I just want to move it positive. What about number 11? Okay, again, multiplication one. Now, I want to make this as easy on myself as possible. Save myself as much work. So I don't want to just multiply and do like a 2 by 3 box. And I want to, because I'm going to have to simplify it, and then I'd multiply and then have to do some kind of crazy factoring. I want to factor now, cancel stuff out, and then multiply whatever I have left. So let's see, what can I factor with this one right here? Well, I can just factor x out. That's about it. Okay. Can't do anything with that denominator. Let's see up here. That's going to be 2 parentheses. It's going to be an x and an x. 6 would be 2 times 3. And they both need to be negative. I had to make negative 5 and still multiply and make a positive. And then 4x is just going to stay 4x. Now, is there anything I can cancel out? Well, let's see here. I have x minus 2, x minus 2. I have just an x, and then another just an x. And then I have these two on top. They don't cancel each other out. So I'm going to write my answer. And I can multiply them together, or I'm perfectly okay with leaving them factor. X plus 3, x minus 3. I'm just going to leave them factor. Over 4. Let's look at number 16. Number 16, division. And that really means I'm going to get exactly the same way as multiplication, except I'm going to flip the second one. Okay? So let's see here. It's still going to be the same way, so the first thing to do is factor. I'm going to factor the first one. What can I factor out of this? Well, I can factor a 4 out, and I can factor an x out. And that leaves me with x plus 3. This one right here, 2 sets of parentheses. X, well, that's going to be 3 and 1. That one's got to be positive, that one's got to be negative. Times, I'm changing it to multiplication because I'm going to flip this one right here. Well, that means this part right here is going to be on the top here. Is there anything I can do to factor this? Well, I can factor a 5 out. And that leaves me with x minus 1. And then the top, I have 4x. Now, we'll cancel stuff out. I have a 4x and a 4x. Those are cancel out. Let's see here. I have an x minus 1, and an x minus 1. I have an x plus 3 and an x plus 3. What's left? Well, in the top, I'm left with a 5. And the bottom, well, nothing. Now, I'm not going to put 0 because whenever something divides by itself, I still have a 1. So I have 5 over 1, or just 5. Let's move on to number 17 again. It's the same way. I picked this one because it doesn't. The second one's not a fraction, so I thought that might confuse people a little bit, but it's not that. Let's go ahead and start off with this. Factor this. X 14, that's 2 times 7. It needs to be, let's see, that one needs to be positive, that one needs to be negative. The bottom's x plus 3, change the multiplication. Now I need to flip this one. Remember, I could write it as over 1. And so when I flip it, the 1 goes on top, the bottom becomes, well, let's see, what do I factor that into? X and x, and that'll be, let's see here, 2 and 2, and both will be negative. Okay. Now I can cancel stuff out. Not a whole lot cancels out here. I can cancel out 1 of my x minus 2's with that one. And that's about it. All right. So write my answer. Move my space a little bit. I have on top x plus 7. And on the bottom, I have x plus 3, x minus 2. All right. Number 18. Number 18 says we have a circular cylinder. Circular cylinder. And they tell me some stuff about it. I should probably go back and let you see the problem, and so I can remember all the details. Oh, well, so they want to use the least surface, at least amount of material as possible. And one measure of this is the surface area divided by its volume. So the smaller the ratio, the more efficient the packaging is. Okay, so the surface area to be small, volume to be big. So a company makes a cylindrical can to hold popcorn, and they're designing a new can with the same height and twice the radius of the old can. Okay? So first can has a height and radius, second can has the same height, but twice the radius of the old can. Let's see what that changes. All right, so they said, well, first write the S over V. Okay. So it says write S over V. Now I wrote out the formulas. S for surface area, V for volume. Okay. They didn't give those, so they expected you to know those or look those up. So surface area, volume. I'm just gonna write those over here. My S is 2 pi r squared plus 2 pi r h over pi r squared. Okay. All right, there it is. I want to simplify it a little bit because again, that's really what they're trying to get me to do. Well, how can I simplify this? I can cancel out a radius in each one of these. So cancel, 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 giving me 2. I can cancel a pi out as well. I can't cancel a h out because this one doesn't have an h. So 2r plus 2h over rh. Okay, so I end up with this right here. Okay. Recording. It says, what is the SV, or that ratio, for each of my cans? Okay, well, this is what it is for the first one. What is it for the second can? Well, it says I'm going to leave height the same, but I'm going to double the radius. Right? If I double the radius, we'll say call this one can 1. If I double the radius, we'll call this one can 2. I'm going to substitute 2r, 2r. All right, and for r, doubling the radius. And then let's see if we can simplify. Well, if I try to simplify this, 2 times 2 is 4. So I get 4r plus 2h over 2rh. Okay. And then now I can simplify this because these are all divisible by 2. This becomes 2r plus h over r h. Okay, divide everything by 2. Well, so this is my new SV. So that's the first one. That's the second one. I want this to be a smaller ratio. I want this to be smaller than that. Well, is it? Well, let's see here. So far, it looks a lot like 2r, 2r. The bottom's RH. But here's the difference. This one is 2 times h. This one is just h. So this fraction would be smaller than this fraction because this one has 2 times h. This one's just h. So this was part B. Part C was, well, did they help themselves by making this new can as far as efficiency? And yes, the new can is more efficient. Okay. All right, well, I hope all that made sense. If not, make sure you send me a remind message and I'll be happy to meet with you individually. Yeah, have a good day.